Hi everybody, welcome to lesson 9, which is called completing the square. And completing the square is going to be our next technique to solve quadratic equations. And it goes hand in hand with the last lesson of using inverse operations. So the next few lessons all go hand in hand where we practice and develop this idea of completing the square. So to get us started, express each of these perfect square binomials as a trinomial in standard form. So remember, when I do x plus 3 squared, x plus 3 times x plus 3. I want to find the product of x plus 3 and x plus 3. So I get x squared, 3x, 3x, and 9. So the trinomial x plus 6x plus 9. That's a perfect square trinomial because I can write it as something squared. Pause the video and try the next one. So I have x plus 5 and x plus 5. So I get x squared, 5 times x, 5 times x, and 25. So the trinomial that comes from that square is x squared plus 10x plus 25. This last one's got that a, but that's okay. We can do it still. X plus a times x plus a. X squared, ax, ax, a squared. So how many ax's do I have here? Well, I have 2 of them. So x squared plus 2ax plus a squared. So notice here, when we square these binomials, I actually make a physical square. X plus 3, x plus 3. They're the same sides. X plus 5, x plus 5. X plus a, x plus a. These trinomials, these perfect squares, are going to be coming up later on. Hence why the lesson's called completing the square, because things are going to be squared in this problem, in these problems. So let's go backwards now. Here's a trinomial. Factor it for me. So when we factor trinomials, we make our box and we go backwards. We ask ourselves 2 questions. We say, self, what multiplies to 36 that adds to 12? What multiplies to 36 and adds to 12? Well, I think it's 6 and 6. So x plus 6 plus 6. Notice I made a square here. It's the same factors on both sides. It is x plus 6 times itself. So it's x plus 6 squared. It's a perfect square. The next one looks basically the same, but it's x squared. Same question, what multiplies to 36, but what adds to negative 12? Well, I'm multiplying to a positive, so they're the same sign, which means they're both negative. So I'm thinking it's negative 6x and negative 6x. X minus 6 minus 6. I know it's weird with the negatives, but we still made a square. It is x minus 6 squared. We physically made a square here. These side lengths are the same. Pause the video and try the next one on your own. What multiplies to 100 that adds to 20? Well, when I think of 100, I think of 10 times 10. That adds to 20. So notice on the diagonal here, weren't these numbers the same? These numbers on the diagonal were same, giving me that square, x plus 10 squared. So we're going to be using this idea of creating squares to go through with this process, this algebraic process called completing the square. Happens to be one of my favorite things we do all year. Can I factor this trinomial? Okay, so we've got a trinomial here, and I want to factor it. Well, I know how to factor this. I ask myself 2 questions. I say, self, I hope you said it with me, what multiplies to 3 and adds to 8? What multiplies to 3? 1 times 3. Does that add to 8? No. So factoring does not work. We cannot factor this expression. And a lot of polynomials we run into, we can't factor, which means there's probably irrational solutions if I was to solve this, if it was equal to 0. So completing the square is going to give us a way to kind of factor things. There might be some leftover stuff, but it gives me this way to factor when I really can't factor it. And it's this different process called completing the square. So here's how we do it. We make a square. I'm going to ignore that 3 right now. So I have x squared plus 8x, and I'm going to make a square to be completed. I've got x squared here, but watch what we do. I'm not putting the 3 there. I'm ignoring that 3. That 3 doesn't matter to me. I'm going to take my 8x, and I need to make a square. Well, how did I make squares here? I take that middleman and cut him in half. So I'm going to take that 8x and make it 4x and 4x. So that way, on the side of my box, I'm making a square. X times x plus 4 plus 4. We just made a square by cutting that middleman in half. Well, why do we call it completing the square? Because look what we need to do right now. We need to actually fill in this missing piece here and complete the square. 4 times 4 is 16. But I don't have a 16, I have a 3. So watch what we do. This 16 I like to call like our magic number. So I have x squared plus 8x. I want a magic 16 there, so I'm going to put a plus 16. But you can't just add 16 wherever you want. You have to counteract it. I need to counterbalance adding 16. So on the outside of that set of parentheses, I'm going to put a minus 16. But we can't forget about this 3. That 3 was there. So watch what I did. I rewrote that expression, x squared plus 8x plus 3. But look what I stuck in there. I stuck in a 0. But I didn't write 0. I wrote 16 minus 16. I didn't change the value of this expression. I changed the way it looked. So that's kind of the second step. The first step is to make a square. Then you complete it, complete the square. And that magic number gets added and subtracted. You stick it into that trinomial, you add it and subtract it. And why did I do that? Because I can now factor that trinomial. X squared plus 8x 16 is what's in this box here. It's x plus 4 squared. I just made a perfect square by doing this. And then what's my little leftover piece? My little leftover piece here is negative 13. That's the process of completing the square. We turned a trinomial into something equivalent to that trinomial that involves a square. X plus 4 squared minus 13. Looking forward, we're going to use this with inverse operations, but I turned a trinomial into a perfect square. We draw the box, we complete the square, add and subtract, factor it, but you don't really need to factor it, you just look outside the box. What's outside the box? X plus 4 squared. This is what we spend the next 3 lessons doing. So our fluency with this is going to develop over time. So write an equivalent expression for each of the following trinomials by completing the square. All right, I'm going to walk you through this one. So let's look at these 2 guys here. I don't care what the constant term is. All I care about is these first 2 right now. And what I do is I draw a square. I have x squared. And what do we do to our middleman? We take our middleman and cut him in half. We cut our middleman in half so that the outside of the box is always the same, because I want to make a square. Negative 2 and negative 2. Which gives me, how do I complete this square? What's the number that completes it? Negative 2 times negative 2 is 4. That number is always going to be positive. That should always be a little check. It should always be a positive number there. 4 is the magic number, so we add it in. I rewrite it. X squared minus 4x. Add in the magic number. And subtract the magic number. So I group those first 3 terms and then just have my friends on the outside here. Why did I group those guys together, those first three? Because that's what's in the box. The box is x minus 2 squared. And who's on the outside? 11. That's how we completed the square. If you feel good, pause the video and try this one. If not, keep watching and I'm going to go through it step by step again. We ignore the constant. I'm completing the square right now, so I'm going to make a square. X squared. I cut my middleman in half. I cut this term in half, negative 1x, negative 1x. Let's fill out on the outside, x, x, negative 1, negative 1. So how do I complete the square? I complete the square with negative 1 times negative 1 is 1. But that's not what I have, so I've got to stick it in. X squared minus 2x plus 1. But I can't just add plus 1. I've got to counteract it. I can't just add 1 to something without changing its value. So I'm going to do a minus 1 on the outside to keep everything balanced. And who comes along for the ride? That negative 15. Last step is to factor. You could have picked any number. You could have picked plus 100 and minus 100, plus a bajillion minus a bajillion. We picked 1 is because that's the number that turns this into a square. It turns it into x minus 1 squared minus 16 on the outside. So you factor the first three and just combine those numbers on the outside there. X squared minus 3x plus 10. Okay, so we look at the first two terms of the trinomial, and we make a square. Well, who cares? Cut it in half. Negative 1.5x, negative 1.5x. I know it's not pretty, but I can still cut negative 3 in half. There's just decimals involved. That's okay. X times x, negative 1.5 and negative 1.5. So the question becomes, what's the magic number that completes my square? I want to complete my square with negative 1.5 times negative 1.5, which is, my calculator just told me 2.25. So that's the number I'm going to stick in. I'm going to stick in x squared minus 3x plus 2.25. But I can't just add it in, I also have to subtract it away. Minus 2.25 plus 10. So again, there's the magic number added in inside that set of parentheses, and then I have my magic number on the outside there. It looks different, but I'm not changing the value. And then I have no idea how to factor this, so I'm just going to look outside my box. It's x minus 1.5 squared. And then I have 10 and negative 2.25, which becomes a positive 7.75. That's how you complete the square. What's nice about completing the square versus factoring is there's no thinking. You just do the process. There's no what multiplies to this and adds to that. You do the process. That's why I like it a little bit better than factoring in some cases. Pause the video and complete the square here for me, and then turn it back on and check if your work. Cut my middleman in half. $100 is the magic number that completes my square here. So that's the number I'm going to stick on into this trinomial. X squared plus 20x plus 100. But I can't just add 100 to something. I have to counteract it. So I'm going to subtract 100 from that expression. And then negative 40 was there to start with. How does that trinomial factor on the outside? X plus 10 times x plus 10. We literally made a square. And I have a negative 140 here. That's the process of completing the square. I've got 3 more problems down there below. I'm not going to spend time in this video because doing them, it'll be too long. You don't have to do them, but if you want some weirder, harder practice problems, I'll have the answers to them in the OneNote if you want to look at them later on. Let's do 4 and 5, and then we'll call it a video. How's that sound? Write me two equivalent expressions by factoring and then completing the square. So let's compare our two procedures here that we've learned so far. Factoring is what we spent the whole month of February doing. Completing the square is what we just learned. So let's factor first. Let's take this trinomial and factor it. Well, how do you factor it? This is called standard form that we're starting with here. This is called standard form. Well, how do I factor it? It's a trinomial, so I ask myself two questions. I say, self, let's make the box. You don't have to make the box, but I want to show you how we use the box differently. R squared, and we're factoring, so the constant goes in the corner. What multiplies to 3 and adds to 4? What multiplies to 3? Well, 1 times 3. Notice we didn't make a square. Those aren't the same numbers. Factoring is you make rectangles, actually. So factoring, who cares what's on the diagonal? That's the multiplying and adding to piece. R times R, plus 1, plus 3. So what are my factors? R plus 1 and R plus 3. That's the factored form of that trinomial. It's equivalent. It's equivalent. It looks different, but it's really the same thing. That's one thing I can do to a trinomial. Or what we just learned is we could complete the square to make another expression that's equivalent to it. So I'm going to put R squared in the corner. And this time, when I complete the square, we cut the middle man in half. Remember, we don't put the constant in. That's what we're trying to find right now. We're trying to find the magic number that makes it a square. R plus 2, which gives me a magic number of 4. 2 times 2 is 4. We stick that 4 in. I want to have a plus 4 there. But I can't just add 4, I also have to subtract 4, and the 3 comes along for the ride. So look at that. It's a very different process than factoring, even though they look very similar. So finally, I get R plus 2 squared outside of the box minus 1. It looks different, but believe it or not, all of these expressions are equivalent. They look different, but they're really all equal. And this is going to come up a lot in Unit 9, where we compare what these three expressions tell us, because they tell us a whole bunch of good information. But that's for next unit. Last one of this video. Explain why I can't solve this by factoring. Well, if I was factoring, I'd ask myself, ready, self, what multiplies to -7 and adds to -8? Well, the only way to get -7 is a 1 and a 7. But I can only have one positive and one negative. The only way to get -8 would be to be both negative, so I can't do that because one has to be positive and one has to be negative. So we can't factor it. So when factoring's not an option, we now have this new tool called completing the square. Completing the square always works. It might not be pretty, but it always works. So let's complete the square on this trinomial. Let's change the way, actually leave myself some space here. Let's change the way this trinomial looks. We look at the first two guys, and we make our square. X squared, cut the middle man in half. X times X, -4, -4. Their product is 16. That's the magic number that completes my square. So I can rewrite this trinomial now. I can rewrite this trinomial as x squared minus 8x plus 16. 16 is the magic number I need to add. But I'll also have to subtract 16 so it stays equivalent. Finally, x minus 4 squared, that was the box, x minus 4, minus 23. And hopefully this is the aha moment where we connect this lesson to the last lesson. I can now solve when that equals 0. Why? There's only one x. So now use inverse operations. The zero product property wasn't going to help us out here, but inverse operations will. Inverse operations will. I took a trinomial that had x twice and turned it into a trinomial with only one x. So let's add the 23 over. How do I undo squaring? I take the square root. So x minus 4 equals plus or minus. I hope you remember that. Remember, when you take the square root, there's a plus or minus in front of it. And the final step is to add the 4. 4 plus or minus the square root of 23. So hopefully you just saw what we did there. We took something we couldn't factor. We completed the square, and again, we're going to spend the next 2 lessons after this practicing this. We complete the square so that we turn it into something where we can use inverse operations. So now we have 2 tools in our toolkit to solve. We can solve by the zero product property, or we can solve by completing the square. So for homework, at the end of this lesson, I've got 6 things where I'm just asking you to complete the square. No solving, just complete the square. And then I've got 1 where I ask you to complete the square for me. See you in the next lesson where we'll be completing the square a whole lot more.